So I hope you are able to understand that sound is a longitudinal wave, and longitudinal wave proceeds as a series of compressions and rarefactions. These compressions and rarefactions could be explained as a displacement wave, they could be explained as a density wave, they could be explained as a pressure wave. Okay, now let's try to understand what is the speed of sound. Suppose a sound is progressing in a particular medium, what is the speed of sound? So what we will do for our analysis is that suppose this is a medium through which sound is progressing, we will look at a particular zone. This is where initially I had my x, this is now x plus delta x. So here the displacement was 0, and here it becomes s plus delta s. Okay, so now the gas here in between this has been moving. So there is a pressure on this side, P0, there is a pressure on this side which is going to be P0 plus a delta P. So now because of this pressure there will be a force acting on this, then there will be a force acting on this. So now because of this difference in force, the mass of gas which was there between it is being accelerated. Now if density of the gas is this, the mass of the gas is this into delta x. So this is the mass of gas which is getting accelerated. Now let me find out what is the force on acting on it. So the force acting on it will be the difference of these two. So the difference. So let me first define S0 is equal to S is equal to S0 sine omega t minus kx. Already we have found out that in such a case P is equal to P0 cos omega t minus kx, where P0 is equal to B K S0. Okay. Remember here we are talking about the pressure. Okay. So now if we go by this, then I can say that delta P. I can say that delta P is going to be equal to P0 K sine omega t minus kx. So that is going to become equal to B K squared S0 sine omega t minus kx. So now this is the delta P. Okay, so now delta P into, now I know S is equal to S0 sine omega t minus kx. So okay, so now we just have to know what is the force acting on it. So the force acting on it is this into delta x. So it becomes equal to B K squared S0 into sine omega t minus kx into delta x. So this divided by the mass. This divided by the mass. Mass is rho A delta x. Okay, so here also an A delta x will come. The difference in pressure into the area. So the area delta x will get cancelled, and I will get an expression that A is equal to B K squared S0 by rho. This is the acceleration of the body. Okay, now if this is the acceleration of the body, now I can say that okay, there is a sine omega t minus kx. There is a sine omega t minus kx. So this is the acceleration of the body. Let me go to a new page and then let me work with this. So I have A is equal to B K squared S0 by rho sine omega t minus kx. So now this is the acceleration of the body. Now this acceleration of the body can be written as d squared s by dt squared. Now I am given that s is equal to S0 sine sine omega t minus kx. There is a negative sign here. I hope you will remember that. See that a negative or positive doesn't make much of a difference. Okay, so we just trying to find out what is the velocity. Now d squared s by dt squared will be the second differential of this. So the second differential of this will give you S0 k squared sine omega t minus kx. So now this must be equal to, with a negative sign of course, this must be equal to minus b k squared S0 by rho into sine omega t minus kx. Now this and this gets cancelled. This s0 k squared, s0 k squared gets cancelled. Okay, there is a small issue. I have to sort it out. Just give me a minute. See, when I differentiated this, I have to differentiate it with respect to time, but I differentiated it with respect to omega x. That's why I ended up with an error in this. There's an error in this. So let me redo it again. So if s is equal to this much, then ds by dt is equal to s0 omega sine, sorry, cos omega t minus kx. When I differentiate it again, I'll get d squared s by dt squared equal to s0 omega squared sine omega t minus kx, again with a negative sign. So this is equal to minus b k squared s0 by rho into sine omega t minus kx. So the sine omega t will get cancelled, the s0 will get cancelled, and we have an expression that omega squared is equal to b k squared by rho. So let me work with this particular expression. Okay, so omega squared is equal to b k squared by rho. Now if I have a wave which is equal to some p is equal to p naught cos omega t minus kx, or s is equal to s naught sine omega t minus kx, this omega is the angular frequency 2 pi f, and this k is the wave number 2 pi by lambda. Now I know that frequency into lambda is equal to velocity. So if I multiply by a 2 pi and divided by 2 pi, this will give me 1 by k, this will give me omega. In other words, v is equal to omega by k. In other words, omega squared by k squared is equal to v squared. And if you look at your previous expression, you will get omega squared by k squared is equal to b by rho. This is equal to b by rho. So now if omega squared v squared is equal to b by rho, so you can say v is equal to root over of b by rho. So this is what it is. Okay, so now this is what is the velocity of a gas in any medium. So velocity of a gas in any medium is equal to root over of b by rho. Now in case the gas is traveling through a, in case the sound is traveling through a gas, this rho is mass upon volume, so number of moles into molar mass by volume. Then the bulk modulus is equal to P. For a gas, bulk modulus is equal to P. I'll explain it to you again. So when I work on that, I will get that velocity is equal to root over of P divided by this, that is equal to PV by Nm. Now we know that PV is equal to nRT. So if I substitute that, the Nn will get cancelled, or velocity of a gas is equal to root over of RT by molar mass, which means that lesser the molar mass, greater will be the velocity of sound in the medium. Okay, so I hope you are able to understand this. Velocity is inversely proportional to the molar mass. Now this is what was suggested by Newton. Laplace brought out a condition, a rectification to this. All that Laplace said is that, look, it is not that the gas is, when you say that PV is a constant, you are trying to say that it is an isothermal process. That is, the propagation of gas is an isothermal process. Laplace showed and proved that the propagation of gas is not an isothermal process but an adiabatic process. In an adiabatic process, I know that PV power gamma is a constant. So from here I can say that P into gamma into V power gamma minus 1 plus V power gamma into dP is equal to 0. In other words, this 2 will get cancelled. In other words, I will get V dP is equal to P power gamma. In other words, the bulk modulus will not be P, but the bulk modulus will be gamma P. So when I substitute that, the equation of the velocity of a gas, the corrected equation of the velocity of a gas is V is equal to root over of gamma RT by M, where gamma is the adiabatic constant. R is the gas constant universal gas constant, which will always be applied as 8.31. T is the temperature, which will always be applied in Kelvin. Then m is the molar mass. M is the molar mass of the gas. Okay, so I'll get V is equal to root over of gamma RT by M. So please work on it. Just revise this.